Oh, good noon, everybody. I'm Paul Schroeder, the Executive Director of COPAFS, and I want to welcome you to today's webinar entitled Introducing the DDI Metadata Standards in Support of Transparency in Federal Statistics. Our presenter today is Dan Gilman from the Office of Survey Methods Research at the Bureau of Labor Statistics. But before we get started, I also want to thank Peggy Adams with the International Association for Social Science Information Service and Technology for suggesting today's talk, and of course, Dan for agreeing to present. Just a friendly reminder that we always listen to our valued members, so if you have any ideas for future webinars, please don't hesitate to reach out to me. Also wanted to let everyone know that we will have time after Dan's presentations for questions and discussion, so be sure to stick around for that. And now, without further ado, I will turn it over to Dan.
Thanks, Paul. So I'm Dan Gilman at the Bureau of Labor Statistics, and I'm going to be talking about the DDI metadata standards and transparency in federal statistics. Next slide. So here's the brief outline. I'll be talking a little bit about transparency, then some about metadata, and then standards, in particular the DDI standard. Next slide. So transparency is something that many people talk about. The term is in lots of reports. It's presented as a worthy goal, but very often the term is just used and it's not really defined. Very often it's stated in conjunction with privacy. The idea is that transparency and privacy have a little bit of a tension, that to make things entirely transparent might mean that privacy concerns are violated. So there can be a problem between the two. But so the question is, what really does transparency mean? And so if we look at the dictionary definition and take one sense of the term, transparency is a condition of being easy to perceive or detect. And I think that's what we mean when we talk about transparency for statistics. Next slide. So the report of the Commission on Evidence-Based Policymaking, the promise of evidence-based policymaking, had a description of transparency, very general, giving the public information on how the government is using their data to improve its effectiveness and efficiency. Interestingly, this appears after they've used the term about 48 times, but we can take that as sort of a general definition or guidance about what transparency means. Next slide. But then the National Academy Committee on National Statistics report, Transparency and Statistical Information for the National Center for Science and Engineering Statistics and all federal statistical agencies, that came from the Panel on Transparency and Reproducibility, has a more specific definition of transparency, and it's the provision of sufficiently detailed documentation for describing the processes for producing official estimates. And it's this definition that we'll look at in slightly more detail here. Next slide. So what's evident here is that transparency requires a level of documentation. We need to be able to find, understand, and use objects like variables, data sets, data processes, so forth. And it's those actions that really underlie the idea that something is transparent, especially the ability to find and understand things. But the documentation that's required is situation specific. Different documentation is needed depending on the needs and the situation. So let's look at a very simple example of a way of describing variables versus describing questions in order to make them understandable. Next slide. So here's a simple example of how we might describe a variable. We want its name, a definition, the data type, the universe, that is who does the variable apply to, and the set of allowed values. And there's probably other information that we'd want to know, but that's the basic set. Next slide. And we can look at the same thing for a question. If there's a name for the question, we want to know that. We want to know the links to subsequent questions. We want to know what the previous question was or questions that led to the particular one we're looking at, the universe, who was asked the question, the response choices, and the question text. Now, questions and variables, of course, are fairly tightly linked, and so these descriptions are similar, but they're definitely not the same. And so the takeaway here is that even with similar things, questions and variables, we have different needs around the documentation for each individual one. Next slide. So variables and questions are described differently. And that means that since we need documentation for transparency, the needs for transparency differ from situation to situation. Next slide. So this leads us to a discussion about metadata. So when we talk about documentation versus metadata, usually we're saying, oh, that documentation is often in the form of informal textual descriptions, whereas metadata is more formalized. But the terms can be used interchangeably and often are, and this leads to a general definition of metadata is that it's data that we use to describe or being used to describe some objects of interest. Whether that's informal text or whether it's formalized, doesn't matter. We can refer to all that as metadata. And that differentiates metadata from data in general, that metadata is metadata when it's being used to describe. And that's how that's what makes it metadata. Next slide. So when metadata are formalized, they're based on a set of elements. The elements are used in the description of every object of some kind or class. So think back to the example that I gave about describing variables, the name, definition, universe, data type, and allowed values are elements for describing a variable. Same with the question, the name, the text, previous questions, the subsequent questions, and the response choices. Those are elements needed to describe a question. We can organize the elements through something called a schema. And basically a schema is just a set of rules, a set of formal rules. And they include, but are limited to, the rules about the format for the values and the data types that apply to each of the elements in the schema. And they also include relationships between the elements. Sometimes there needs to be a relationship to indicate special considerations. And so those are important components of what a schema is about. The set of values for each of the elements in the schema, if we consider it as a complete set for all the elements, we call that an instance of the schema. So we'll talk about that a little more. But there's all of this leads to what's really concerning the advantage of metadata management, which is about reuse. We want to be able to regularize things. We want to regularize the description, say, of variables or questions. And so we want to be able to apply the same elements every time we describe those things. And if it turns out that a value is the same across many instances, we want to be able to link that one value to all those instances, because we care that things share information. So the idea is that we write metadata down once, but we use it many times. And this is an important idea. Next slide. So going back to our example of the elements for describing a variable, we have a schema here on the left. That's our set of elements that we talked about before. But we can also lay out an instance, and what I've done here is described a marital status variable and laid out what some instance values might be for a variable of that kind. We don't have to belabor that, but it just illustrates how you might provide values for each of those instance elements. So at the bottom, the set of 11 values is, I've got pairs, the codes S, M, D, and W for the categories single, married, divorced, and widow. Next slide. So, as I said before, we can also think of metadata as more traditional documentation, and it's actually we're able to translate between the two kinds. If we start with a schema and have an instance, and we look at the combination of the instances, the values for each of the elements and the elements themselves, the combination tells a story, which is equivalent in some way to the textual documentation that you might write down. And so what I have below is the textual version. It's a little bit stilted, but it is still a textual version of the description of the marital status variable that I had on the previous slide. I won't go through it, but basically I've just written out in prose everything that the combination of the elements and their values say. So the story is, in a sense, the textual documentation. Next slide. So in using metadata to achieve transparency, which we've been basically talking around, there are two essential criteria. One is that the instance values for a schema must adhere to the rules of the schema. In other words, we have to fill out the values in the right way, whatever that means. But in addition, the combination of the values and the schema elements have to tell the right story. So in other words, the description that we give has to be correct in some way. We can fill out a schema and get everything right syntactically. In other words, we followed all the formatting rules, but we may not actually be providing the right values. And so we need to make sure that they're right. So more technically then, when we adhere to the rules of the schema, we call that conformance. And what that essentially means is that we've satisfied all the requirements that the schema states. So if we've satisfied all the requirements, it said we've conformed to the schema. But as I've said, we still need to know that we're telling the right story. And when we look at the instance values that way, that really gets to the idea of metadata quality. Is the metadata the right metadata? Do we have high quality metadata? Next slide. So going a little further now with schemas, they're an example of what's known as a technical specification. Now you can write all this out in prose, or you can write it in a formal way, but when you lay out what's required to describe, say, a variable, that is a technical specification. And metadata standards contain technical specifications for metadata. The scope of the standard, that is what the standard is designed to address, directs the kinds of objects, the kinds of things that can and should be described by the spec. Adherence to the spec is conformance to the standard. That is, you're conforming to a technical specification or schema. So therefore, metadata standards support transparency because you can conform to them. And we've seen that conformance is necessary to be able to make sure that we have the right metadata in order to show that you can find and understand and use some object, a variable, a data set, questions, questionnaires, and so forth. Next slide. So now we can talk a little bit about standards, or actually the rest of my talk is going to be about standards. So in general, why do we care about standards? Why do we use them? First of all, standards that are open for anyone to use and develop through a consensus process generally have broad applicability, because when you're developing something through consensus, then there's that everyone has basically agreed to what the spec does and says. So adhering to standards and conforming to standards reduces development time, because then an underlying model for the metadata that you have for some system doesn't have to be designed. It's already designed for you. And this is a huge advantage. For one thing, if everyone is using the same or similar standards, then the elements are the same or similar, which means that when you conform to a standard, you promote interoperability. So we have 13 principal federal statistical agencies. If we're all using the same or similar standards, we know how each other is describing their objects, their data, and we don't have to ask to understand how they're describing something. We already know in advance, and this promotes interoperability. It also promotes transparency across the agencies, because similar kinds of objects like variables and data sets and so forth are described in the same way. We already know that they're going to be described in that way. We can write systems that allow us to access variables from multiple agencies at once, and we know how to do this in advance because we already know what the description looks like. Next slide. So there's a particular family of standards that I want to discuss, and these are known as DDI, or the Data Documentation Initiative. So the DDI is not a single standard. It's a suite of standards and actually other products that that can be used either by themselves or in conjunction with the standards. Of course, the standards were developed for the social, behavioral, and economic data, but some of them are more widely applicable. The standards are developed under a consensus process, and they're equitable in the following sense: that they're open. That is, anybody can join the process to develop one of these specifications in the suite. The participation is balanced. That means that participants come from all the stakeholder communities that are mostly interested in the development of the standard. The developments of the standards are visible. That means you can always inspect the standards as they're being developed or being modified. And the process is fair. That means that every participant has the same rights. And that's extremely important. Nobody, there are no 500-pound gorillas or 1,000-pound gorillas in the room. Nobody has more say than anybody else. Next slide. So the work for DDI is managed by a consortium called the DDI Alliance. It's a consortium of member organizations. These include national statistical offices, social science data archives, university data libraries, research centers, other consortia, and some other organizations. There are over 40 members. BLS is one. I strongly recommend that other agencies join as well. The Alliance can use more members. And the Alliance, the home of the Alliance is under the University of Michigan. Next slide. So getting into a little bit more of the meat of what DDI is about is there are 3 different standards under the DDI suite. So one is called COBOOK, there's Lifecycle, and cross-domain integration. Now, and I'll refer to it as CDI. CDI actually is still in draft, but it's very close to being finished and will be published soon. So I'm including it in the discussion. There are also some other products of note. There's something called XCOS, or Extended Knowledge Organization System. I will describe this a little bit. SDTL for Statistical Data Transformation Language. And there's a set of controlled vocabularies for promoting metadata interoperability. Basically, the controlled vocabularies provide a common set of terms that are instance values for some elements in the DDI standards. And this definitely promotes interoperability, because then you know that the same term is being used across instances. Next slide. So COBOOK is actually the first of the standards that was produced under DDI. They're referred to as DDI 2.x. The current version is 2.5. It's designed to describe a single use survey or a single instance of a survey. or a social science experiment. The principal class or focus is called a study, which is essentially an experiment or a survey, and then there's a number of metadata elements that support that. But reuse is not part of the design. In other words, a description under COBOOK is expected to be standalone. It describes the study, the data that it was developed for, and there aren't any inherent relationships within COBOOK to other COBOOKs. But the COBOOK is written in XML schema, and therefore it's pretty much immediately implementable. It is not a conceptual model. It's in an implementable form. Next slide. There's, as I said before, it was the first standard under the DDI suite. DDI began in 1995. This work was based on some work on electronic code books in the 1980s. And at first it was implemented using SGML, which is a markup language for document producers. Something called a data type definition, DTD, was the first schema language for XML, which came out of the SGML community. But now XML schema is the way that a schema is organized using XML. So DDI COBOOK is described using XML schema. Next slide. There are many implementations of DDI COBOOK, but one in particular is called the International Household Survey Network. It's managed by the World Bank. They help developing countries with their statistical operations and use COBOOK as a way of describing the data and the statistical operations that they're employing. And the important thing is that there are lots of free tools that the World Bank produces, and you can use them pretty much out of the box for doing COBOOK implementations. Next slide. So the next standard is lifecycle. So it's numbered 3.x. The current version is 3.3. And it's based on the statistical lifecycle that came from the UNECE standard, the Generic Statistical Business Process Model. And so basically, the lifecycle allows you to describe the metadata from design to dissemination, all the work that a statistical office would employ. It supports reuse. All the classes of objects in lifecycle can be reused. And when it comes to describing variables, it was the first of several standards, including the Generic Statistical Information Model out of the UNECE, that employs something called the variable cascade. It's a rather sophisticated approach for describing variables and being able to reuse parts of them across time and across surveys. But like COBOOK, DDI lifecycle is written in XML schema, so it's immediately implementable. UNECE GSIM model, though, is just a conceptual model, and it's not implementable out of the box. The newest version of lifecycle, version 3.3, has quite a bit in it, and it includes the ability to describe a sample, questionnaires, weighting, and so forth. So it's pretty sophisticated, especially from the point of view of what national statistical offices do. Next slide. So Lifecycle also has many tools associated with it. Some are open source, especially built by the research libraries. There's also some commercial software. BLS has an application using Lifecycle for the consumer expenditure surveys. The idea is to document their yearly public use microdata release. Currently, the system is being employed internally to be able to track how the data are received from the Census Bureau, who collect the data, through all the processing steps out to the point at which the public use microdata is created. So it's an ambitious project. It's still under development. Next slide. There are many national statistical offices that use Lifecycle, and including BLS. Australia, Canada, France, New Zealand, Norway, and others are all using it. It has wide applicability and application. Next slide. So now I'm going to move to CDI, cross-domain integration. This will be numbered 4.x. We don't have a release yet, but it will be 4.1, maybe 4.0. It's actually intended to describe data from any source. So now that we're moving into a realm where we acquire data from other sources and not just traditionally through surveys, we need the ability to be able to describe administrative data and others through a spec that can describe lots of different kinds of data. So administrative data, sensor data, web scrape data, all applicable under CDI. It's a little different than the way Lifecycle and CodeBook were built, because they're built directly as XML schema applications. CDI is being built as a UML model. I won't get into UML, but it's a standard language for creating a model called Unified Modeling Language. And but we've developed an XML schema, what's called syntax representation, to basically to conform to the model. If you're familiar with Resource Description Framework, RDF, or the ontology, the web ontology language, OWL, syntax representations for those are under development as well. Others are possible, like SQL for relational databases. Next slide. So there's some new features in CDI that go beyond what Lifecycle and CodeBook provide. The variable cascade, the description is expanded, so it's even richer than what's in Lifecycle. There's an expanded process model, so we can describe the provenance, how data are generated using CDI. We include something called the datum-centered approach. So the idea is to be able to map a datum as it appears in different data sets across a wide set of processing steps and data dissemination systems. It's particularly useful when the data are represented differently in different areas, but the data still mean the same thing. Next slide. There's an additional new feature with the lifecycle and codebook generally look at data as rectangular. That is, the columns are variables and the rows are units. But in CDI, we've expanded that to include other structures, the long structure, which addresses the needs for event history data, where each record has a unit of a variable and a single value for that variable. There's also key value pairs, which sensor data produce, where the key is some identifier that has to be unpacked so that it allows you to gain access to the further description for that for each datum. And then, of course, we can also handle multidimensional data, which applies to cubes, which we generally represent as tables, and time series. We can tie that back to the microdata through a semantics-based structure, which is quite powerful. And I should have said CDI, not DDI, provides the means to transform from one of these structures to another. Next slide. So that's it for the standard. So in some of the other products, there's XCOS, which is the Extended Knowledge Organization System. It includes extension to something called SCOS, which is Simple Knowledge Organization System, that was built by the World Wide Web Consortium. It's a system that allows you to organize concepts and terms into hierarchies, taxonomies, ontologies, if you know what those are, and it supports the hierarchical relations. So the generic relation, something is a kind of something else, part of, something is a part of something else. So a person is a kind of people are a kind of mammal. A steering wheel is a part of a car. There's also instance. So I'm an instance of a person. It supports levels, so you can document or describe statistical classifications such as NAICS and SOC. And importantly, it allows you to apply a concept to each of these levels. So for instance, you can talk about sectors, the two-digit level in NAICS, and make that meaningful. Next slide. So XCOS is written in Resource Description Framework, which is a web language for actually creating a graph of information. So if you're familiar with graph databases, RDF is very similar to that idea. Since XCOS was developed, SCOS has also been further developed. So there's a little bit of a collision between the two, but so XCOS has added semantics for many relations, but these but some of the additions in XCOS were added to SCOS. So there's still coordination between the two. XCOS is being used more and more as we go, but the INSEE, the Statistical Institute in France, uses it a lot. And there's something called the Alpha Project in Eastern Africa, which maps HIV and AIDS infections in that part of Africa. Next slide. So SDTL is the Structured Data Transformation Language. It's kind of a mid-level specification, an intermediate language for representing data transformation commands. So what it allows you to do in a standard way is create documentation for the process. That it enhances the provenance and the processing of data. you can say what's happened without having to get down into the actual computer language commands that might be used. Plus, it's language independent, so it doesn't depend on things like SAS or R or SPSS and so forth. But it allows you to translate between those languages. So it's a powerful new tool. It was released late last year. Next slide. So the other thing, because it supports documentation, it allows you to translate into natural language. So it takes a sort of a somewhat formal description and allows you to create more textual description, and that text can be classified because the commands are standardized. Next slide. And then the controlled vocabularies, as I mentioned before, these support interoperability. They provide language to consistently record commonly used values for particular elements within the DDI standard. Examples include units of analysis, telephone type in telephone surveys, note type if there are notes taken, what those notes refer to, and there are many more. So this is a powerful way of adding some regularity about what is normally just user-defined text. We now have controlled text to create uniform metadata. And I think that's it. Next slide. Yeah, so that's what I had to say. I'm happy to answer questions. And this is my contact information.
Thanks so much, Dan. We actually have a question in the chat, but for anyone who wants to ask a question in the chat, or if you want to unmute yourself and ask it openly to Dan, please feel free. So first we have a question from Jennifer Bocher. Is there one DDI variable for income across all the agencies? What if they are collected differently?
Sorry, where's, no, there is not. And so the difference is that the idea of an income variable, that would be an instance of the description of variables in general. So how you describe income is defined by whoever has an income variable. The work to develop a single income variable would have to be done, say, by cooperation among the agencies, that there would be a standard way to do that. And DDI doesn't address that. DDI provides the mechanism for recording that, but the work to standardize content has to be done by the agencies themselves.
Okay. Other questions? We have, Sadang has asked if you can give us some examples.
Examples of what kind of DDI implementations? I'm not quite clear. Okay, so as I mentioned in the talk, BLS has developed an application using DDI lifecycle for documenting the consumer expenditure surveys. The work is in no way complete, but the system is in use within the analytical branch of the consumer expenditure survey at BLS. The national longitudinal surveys are considering using DDI at BLS, so there may be a second application. Other agencies, I believe the Census Bureau and the Bureau of Justice Statistics have been looking at DDI. There may be some applications. I'm not aware of how far they've gone, but there are significant applications of DDI lifecycle throughout the world. The midlife US project, MIDAS, at the University of Wisconsin, has an extensive DDI lifecycle application. The Closer project at the University of London has a number of longitudinal surveys that they document using DDI lifecycle there. Several national statistical offices around the world are using lifecycle. Statistics Canada, Statistics New Zealand, I believe Statistics Norway, because they developed a system along with the Norwegian Social Science Data Service, which has now been renamed. But they've built an application that's based on CDI. The other offices, including INSEE in France, are using lifecycle. It's been widely used. COBOOK is being used for the International Household Survey Network, as I said. The Inter-University Consortium for Social and Political Research, ICPSR, at the University of Michigan, uses it extensively. Other data libraries and archives use it as well. Some use lifecycle, but it requires more work because it requires doing the linking to take advantage of the reuse that COBOOK does not afford. But describing individual data sets that archives have is a big application for COBOOK. Hope that answers the question.
So a couple more questions here in the chat. From your experience, what is the trickiest part of DDI? For example, formalizing metadata according to the standard, controlled vocabulary, something else, or culture change?
Well, going from no metadata management to something as complete as DDI, even COBOOK, is a big culture change. And in order to get that change, my experience is that you need buy-in from the highest levels in the organization. So if it's going to be organization-wide, you need buy-in from the top. If there's a program area that wants to implement metadata but not with the rest of the agency, you need buy-in from the head of that department. What I found, and I don't mean anything disparaging by this, is that the upper management and the technical staff get the idea before the mid-level managers do. Mid-level managers are protective of the processes that they do. They're held accountable for making sure that the process as already designed carries through successfully. So if you try to implement a change, they're typically resistant. So you need a lot of buy-in. And so in order to do that, you need to work in small steps, build a pilot system, proof of concept, then build a little bit, once that's accepted, build a little bit of functionality, get that accepted, build some more functionality. So build small steps at a time. That iterative approach makes everyone more at ease with the process because they see small changes at each time and can get used to them. The other thing is that you might plan a particular path, and then it turns out that idiosyncrasies of whatever programs you're trying to describe means you have to do things a little bit differently than you originally planned. When the steps are small, you can make those changes. So I hope that addresses that.
Actually, getting quite a few questions in the chat here. So just go right to the next one. Whose office is responsible for which standards? CDO, CTO, or CIO?
That's a very interesting question. And I'm doing some work at the Department of Labor for the CDO. And we're basically building a data governance program. And the CDO, Scott Gibbons, is adamant in making sure that the management, the quality, the description, the way data are organized and disseminated is those are governance considerations. The systems underneath that handle all of that is an IT problem. So there's a distinction between the governance operations and the IT infrastructure operations, and the results are probably more successful when those separations are made. So the basic answer is the CDO would be responsible for trying to implement a metadata standard. The actual software for managing the metadata would be a CIO problem. I hope that makes sense.
Okay. Next question is, what is the timeline for DDI, CDI, and are there any tools being developed or planned for pilot or prototype projects?
So unfortunately, CDI has been somewhat delayed. And part of the problem has been COVID, that efforts to get the team together to really knock out a lot of the issues that have to be nailed down to a release CDI, we haven't been able to do. I'm a member of that team, and so the work is bogged down a bit. I would say we're delayed probably by about a year. We had hoped to have this out about a year ago, but the work is ongoing. I'm hopeful that the release will happen late spring or early summer. But we're very close, and you can inspect the spec. There's a draft that's available. You can go to the DDI Alliance website, and there's some web pages associated with CDI, and there's a link to the draft, and I recommend that you look at it. And there's some XML that is available, although be warned because there may be some small changes between now and the final release, but there won't be any major changes. Anything else with that?
Just moving to the next question here. Does DDI exchange easily with DCAT? Do you know if data.gov is considering providing DDI metadata? You've
opened a can of worms here. DDI, well, data.gov created a spec for describing data sets. A group that I lead, an ad hoc interagency group on metadata, contacted them several years ago and said, you really need a spec for a data dictionary, and we provided them one. But instead of accepting that, they just created a link to a data dictionary. Well, there's no standard then for describing the underlying variables, and that's probably not really conducive to doing the work that data.gov implies. So they don't have any plans for implementing DDI. I wish they did, or any standard for doing a data dictionary. But DDI could be used to handle the data dictionary part for data.gov. Now, DCAT, actually, the CDI community is working closely with the DCAT community. And in fact, the DCAT community is incorporating some of the variable level description into DCAT as a way of describing things at that deeper level. So I'm not quite sure what DCAT has planned as their result of this. It may just be a recommendation rather than being part of DCAT, but DDI CDI works closely with DCAT, so they're very compatible. And DDI lifecycle is compatible enough with DCAT that they're essentially interoperable.
Great. Okay, next question comes from Bill Wachowski. You mentioned individual efforts such as Consumer Expenditure Survey at BLS. Are you aware of any broader efforts in statistical agencies or elsewhere to coordinate definitions and move to a system like DDI?
I am not. I wish there were. I think that efforts to standardize on a way to describe statistical data is really important, especially as we move to a more automated way of accessing data and also for integrating data from multiple sources. And if we can gain standards on or agreements on instances, on the values for certain say variables, that would be useful because it would enhance interoperability as we try to integrate data from one source to another. Now, there are always specific reasons why some things are defined a little differently than others. And we know lots of, Bill, I know you know lots of examples at BLS where that's true. So I think there would have to be an interagency group that would work on metadata content. The work on a metadata standard, I think, would be separate, but a work on content to try to arrive at a common way of describing many of the standard variables that we have across surveys would be very useful.
Excellent. Our next question is, many projects don't consider metadata management until after data collection. Isn't it important to understand DDI prior to designing data collection?
Yes, absolutely. An old colleague of mine at the Census Bureau used to say, we need to collect metadata at think time. And what he meant by that was when things are designed, that's when metadata needs to be recorded. I think one of the huge impediments to doing metadata management is that, well, it's done after the fact. We put surveys into operation, and then we say, oh, by the way, we need all this metadata so we can describe our data. Well, that's it appears in that way as work because, well, you have to go back and collect it and collate it and organize it and make it look nice and put it into a system. And this after the fact aspect of current metadata management practices, and I'm not saying it's all done this way, but often makes it creates a wall and makes it harder to do this. So yes, we need to plan for metadata management as part of the plan for any new statistical operation.
Great. We've got a couple comments down the chat, but no more questions. Are there any questions? Anyone want to unmute themselves to ask a question? We are a little bit past 1, but I told we're okay.
I can stay if you can.
Okay. Yeah. No, we're good to keep it open a little while longer. We actually just got another question in the chat. Any experience with introduction of standard metadata, for example, introduced for new surveys, programs, and migrate legacy programs as they change?
So my work with the National Longitudinal Survey Group is that if you're not familiar with that, it's a longitudinal survey. They have a cohort that began in 1979. They have another cohort that began in 1997, and they're planning a third cohort. Right now, I think it's in 2026, but that date isn't set. And what they'd like to do is incorporate a more complete, logical metadata management system into their program. And so they're thinking about it. Now, have they made any decisions? No. But they are looking at that. And I think that among the agencies or the national offices around the world that are much further advanced in metadata management than we really are here in the US, they do create their metadata as part of the design, the planning for new programs. So I think actually that in a way it's putting the cart before the horse. I think we need to get metadata management in place in some way before people begin to say, yes, this is something that we need to do in advance as we create new programs.
Excellent. Any other questions for Dan?
Let's see it right now.
Not seeing any at the moment. Dan, any closing thoughts for us?
Not really. I think I answered most of the things that I might say. I mentioned this ad hoc group around metadata that I lead. We meet every 2 weeks. Contact me if you want to join it. There used to be an interagency group called SCOPE, and there was a metadata subgroup that was spawned under that. And we still call ourselves SCOPE metadata, even though SCOPE no longer exists. And I would be happy to have more participants from the statistical offices. So please contact me if you have the interest. We are, our main purpose is to make people aware of more of what the power and benefit of doing metadata management is. The other thing is, I would encourage people to look into joining the DDI Alliance. You can join as a paid member, your organization, or you can join as what's called an associate member, which is a non-paying member. You don't get to vote, but you can participate in all the developments. So, and you know, be part of the conversation and add recommendations. I can't encourage you enough to engage in that. I've been the lone participant in the DDI community from the National Statistical Offices for a while. I want that to stop. Now I can retire, but that's not the way I want that to stop.
All right, well, we will leave it at that. Thank you so much, Dan, for the great presentation, and thanks to all of you for your questions. Really appreciate it.
Yeah, thanks, Paul. Thanks for the opportunity. And, you know, if anyone has any questions or comments, don't hesitate to contact me. Paul, I assume you can make my slides available for people. There, you know, there are no restrictions on their use.
Yes, so everyone, the slides and the recording will both be available on the COPAFS website in the next couple of days.
Okay, great. Right. Thanks, everyone.
Thanks, everyone. Thank you, Dan.
Okay. Take care. Bye.
Take care. Bye-bye now.